Welcome back to Trusted Chemistry Solutions. On today's topic, we'll be talking about elements. Elements as a part or as an example of a matter. But first of all, before I continue, let me first define what an element is. Then I'll now explain to us why the study of elements is very, very important. An element is a substance which cannot be split into any other form by a physical method or ordinary chemical process. Now, from the definition of elements, we say that an element is a substance which cannot be split into any other form by a physical or ordinary chemical process. Again, the word ordinary, as I go further, I will come back to explain this word ordinary chemical process. But by physical process simply means there is no physical process that you can use to split up an element. Elements occur naturally while some occur artificially. That is to say, these elements, artificial elements, are created by scientists in the laboratory. But before now, or right now, about 109 elements have been discovered, including the artificial elements and also the natural elements. These natural elements occur in our environment. They occur as maybe underneath the earth, or also they can be seen in our world, in the air, or they can be found in the air. But that's not really why we're here at the moment. We want to understand the other form of matter. Matter, earlier we have discovered that matter can exist as a solid, as a liquid, and as a gas. It can occur as an organic matter. It can occur as an inorganic matter. Now we want to see also that before now we've seen the word that matter can be formed as an atom, as a group of atoms, or as a group of molecules, or as a group of ions. But in today's lesson, elements, we get to see matter existing as an element. So matter are formed as a result of elements coming together. But we must also understand that elements themselves are matter, because these elements contain also their own atoms. Elements are said to be elements because they have a particular atom that keep on repeating themselves. Each element have a definite and specific type of atom coming together to form that particular element. Every element is considered to be an atom of its own. A matter of its own. So we must understand that in as much as some matter are created by the combination of atoms, by the combination of molecules, or by the combination of ions, some matter are formed by the combination of elements. Even when these elements are not in combined state, they themselves are matter. Therefore, elements are grouped in different forms based on their characteristics, based on their behavior. Some elements are considered to be metals. Some elements are considered to be non-metals. Some elements are considered to be metalloids. Some are considered to be to be the lanthanides, the actinides, and also the sometimes they are called the transition elements. We'll be discussing that more in the periodic what table, where I will teach and explain how this periodic table is being created into groups, period, or row and what columns. But for now, let us concentrate on what elements. An element, example of an element, let us look at hydrogen. Hydrogen itself contains what? Smaller particles known as what? Atoms. That is to say that hydrogen itself is a what? Is a matter. But somehow, other matter also are being also created by the combination of what? Elements. Example is what? Water, which is H2O. You will see that water is actually a what? A compound. But also, we must know that even as much as the compound, it is first of all a what? A matter. So you can see clearly that both the elements themselves that makes up this compound is themselves what? Matter. So there are other types of what element, like I said earlier, that we will see, get to see, at least we get to see the first 20 elements. Like I said again, that matter can come in form of elements, can also come in form of what? In form of compound. Can also come in form of a what? A mixture. Let me say this clearly. These are different forms of what? Matter. This can be gotten from this. Because the combination of what? Elements gives you a what? A compound. Therefore, at the moment, we will not be talking about compound and what? Mixture. We're going to talk about these things in the series. And I believe and bet you that you will get to understand this difference clearer and better. Also, we must understand that some of these elements can occur as an independent entity, while some cannot occur as an independent entity. And also, why did I say that they can occur independently or not independently? Sometimes when they are in a chemical reaction, when they are not in a chemical reaction, when they are not excited, they can never exist as a single entity. Some elements behave in that manner, while some can exist independently. That takes us to what? The types also of elements. Number one type is the what? The monatomic element. Monatomic elements. Number two is the diatomic elements. We also have the what? The polyatomic elements. For the monatomic elements, these are elements that can occur independently. They can occur on their own when they are not in a chemical reaction. But when they are in a chemical reaction, they can exist more than what? More than one. But when they are not in a chemical reaction, they can always stand on their own, independently. Example is the what? The neon. Neon can occur alone. Another one is what? Helium. Argon. These elements can exist independently outside a chemical reaction when they are not excited. But the ones that are what? Diatomic, they don't occur alone. They are not independent. They occur as a what? As a molecule in twos. They occur as a molecule in twos. Example is oxygen. Another one is what? Is chlorine. Another one is what? Hydrogen. Another one again is nitrogen. You see, when they are alone, they can only exist in twos as a molecule. Now, we must also understand that most gaseous elements are diatomic. Most gaseous elements are diatomic. Look at oxygen is a gas, chlorine is a gas, hydrogen is a gas, nitrogen is a gas. We have other ones also that are what? Diatomic. Now let us look at the polyatomic what? Elements. Sometimes we tend to call the triatomic elements, but they are all grouped as what? Polyatomic elements. Number one of them is phosphorus. Which is P4. We also have what we call the sulfur, which is S8. We have ozone, which is O3. You see, these are different groups of what? Elements. Now, why are we even treating this? This helps you whenever you are what? Carrying out the balancing of a chemical reaction. With knowledge of these types of what? Elements, you will get to see when an element is alone, how to balance it. That it can never occur as a single entity, or it can occur as a single entity, talking about the atomicity of that element. You can see clearly here that the atomicity of oxygen naturally, or all the diatomic elements, is 2. Whenever they are what? They are alone, the atomicity must be what? 2. So I'm bringing atomicity here today because it has to do with the teaching. But when we get to the teaching of atomicity properly, you get to understand what it means for the atomicity of an element in a chemical reaction or in a stable state. In as much as we understand the fact that we have the monatomic elements, the diatomic elements, and the polyatomic elements, we must also understand that some elements are said to be metal, some are said to be non-metal, some are said to be metalloid, some are said to be the lanthanide, the actinide, and also have some that are said to be what? Transition what? Elements. But let me explain only but few. But when we get to this type of elements, as the study continues, I'll get to remind us which group they belong. That of what? The metals. Metals ionize. When they use the word ionize because they become what? Either positively charged or negatively charged. But as for metals, they become positively charged. They get ionized when they lost what? Electrons. They have the ability to give out electrons during a chemical reaction. Let me give you an example, like metals like magnesium. Which is number 12, atomic number 12, Mg. Mg is a what? Is a metal. You can find metals in the periodic table in between the group 1 and what? In the group 1 and group 2 what? In the periodic what? Table. These are what? Metals. Why? If you go to group 3, 4, 5, 6, and what? 7, they are non-metals in the periodic what? Table. But how one of the characteristics that we use in identifying metals is that they ionize and become positively charged. They give out electrons, they lose electrons to become what? Charged. Look at magnesium. You can see that magnesium is number 12. That is to say, the first shell contains what? 2 electrons, whereby you have 10 electrons left. You open another shell, you put your what? 8 electrons there. will be remaining what? 2 electrons. Then you bring out another shell and fix your what? 2 electrons. When I'm talking about chemical combination, I will tell us or explain to us why some electrons are close, why some are far apart, and why some are at this point where they are. They are called what? Energy levels. The energy level here is different from the energy level what? Here. The energy level here is different from the energy level what? Here. And we're going to see which one is stronger and which one is what? Less what? Stronger. So we're going to see. Now, for now, let us look at magnesium trying to become what? Ionized. How does it become ionized? It gives out the 2 electrons in its outermost what? Shell. Thereby saying that if you have magnesium, it goes into chemical, it becomes ionized when it gives out what? 2 electrons. 2 electrons. That is to say, it becomes what? Ionized. After reaction, not during the reaction. So it gives electron, it becomes what? Mg2 positive. With the loss of what? 2 what? Electrons. With the loss of 2 electrons. Sometimes you don't need to write the 2 electrons, but already you've seen it here that it's become what? Positively what? Charged with 2 electrons. It means that what? 2 electrons have been what? Given what? Out. Then now if you look at the non-metals, you see that what? They are the ones that receive these electrons that have been given out by what? By the metals. Example of such thing, let's look at chlorine. Chlorine is a non-metal of number what? 17, atomic number 17. That is to say, you have chlorine as an example of a non-metal, Cl. So, now let's look at what happened in chlorine. The first shell is what? 2. Second shell is 8. Third shell is what? Is 7. 1. That is to say, chlorine requires 1 more electron to complete its outermost what? Shell. So what happens? It receives electron to become what? Ionized. It receives electron. It receives electron. While metals give out electron and become what? Ionized in the product side. But for non-metals, they receive electrons in the reaction side so that they can get what? Ionized in the product side. So what happens is this. You have chlorine, for example, right? With what? It's taking one electron. That is to say, it becomes plus what? Plus an electron to become what? Positive and negatively charged with what? With 1. You see, it's receiving one electron and becomes what? Negatively what? Charged with 1 electron. So you see clearly that metals and non-metals are not the same. And as you must know, physical what? Characteristic of metal is that what? They conduct electricity. They allow heat to pass through them. This is another important characteristic of what? Metal. Then lastly, the metalloids. Metalloids are are elements that what? That tends to change between metals and non-what? Metals. One good example of metalloids is the silicon. Silicon, which is Si. Another one is boron. These are common elements in our environment that behaves sometimes like a metal and sometimes like a what? A non-metal. They are said to be what? The metalloids. Example, like I said, is what? The silicon and what? Boron. There are other examples there. If you go to the metal side, you have a lot of them. You have a sodium as a metal, magnesium as a metal. You have other ones as metals. Any elements that are in what? In group 1 and group 2 in the periodic table. Any element that their outermost shell ends with what? 1 and 2 electrons. They are said to be what? Metals. Any element that their outermost shell ends with 3, 4, 5, 6, 7. They are said to be what? Non-metals. While the one that ends with 8, they are found to be what? Gases. Noble gases. When I'm teaching periodic table, I'll get to explain that better. Let's look at the symbols of elements. Why do we need something to represent elements? Elements cannot be written, basically, their full names in a chemical word reaction. It will be very difficult to write sodium chloride as a full name in a chemical word reaction. Now, scientists now decide, okay, it is better we look for a symbol to representing this word element, because sometimes their names can be can be long in such a way that it cannot be written in a chemical reaction. Now, there are three methods used in the creation of the word, the symbol of an element. Number one method is to use the first alphabet of the element, and it's written. Now, here are some elements that their symbol are gotten from the first letter of their names. And the first letter, the symbol is represented in the capital letter. Look at hydrogen is H, oxygen is O, carbon is C, nitrogen is N, fluorine is F, phosphorus is P, and boron is what? Is B. So you see that in this first method of creating the symbol of an element, that the first letter is used for that. Let's look at the second method, the use of first letter and any other letter from their names. Now look at this one, helium. This is why we're using the first and second letter, is because of the fact that what? The first letter has already been what? Been used by what? Hydrogen. So that's why we're giving it now He. Now if you look at all of these up to this point, you get to see that what? The first and second letter are what? Used. But if you look at magnesium, if you find that magnesium, the first and third letter is what is used. Here we are going to be using the first letter or with any other letter from their Latin names. Some elements, their names are got their symbols are gotten from their Latin word names. For example, look at sodium. Sodium Latin name is natrium, which is Na. The reason why we do not use N only is because N has already been used by who? By nitrogen. So we are going to use the first and second. Look at iron. We have it to be ferrum. Ferrum, we are supposed to use F, but because F has been used already by elements called fluorine, so we're going to use Fe. Look at gold. Gold is gotten, the Latin name is aurum, which is Au. Tin is stannum, which is Sn. You see clearly here that the first and second was not used, but the first and the fourth was used. So we see that what? It's not always the case when you use the first and second. Look at the last one there. There are other ones, but let's look at this last one here, which is the fifth, talking about copper, which is cuprium, Latin name, and the Cu is used as the symbol for copper. Now we've come to the end of symbols of an element. Now let us look at the first 20 elements. Let's look at the first 20 elements. One is hydrogen, H, helium, He, lithium, Li. Number 4 is beryllium, which is Be. Boron, which is B. We have carbon, which is C. We have nitrogen, N. We have oxygen, O. We have fluorine, which is F. Then we have neon, which is Ne. Let's go to the 11 to 20. Number 11 is sodium, which is Na. We have magnesium, which is Mg. We also have aluminium, Al. We also have silicon, which is Si. We also have phosphorus, which is what? P. 16, we have sulfur, which is S. We have chlorine, which is Cl. 18 is argon, which is Ar. We have 19 to be potassium, which is K. And lastly is calcium, Ca.